Hello, hello, hello. It's time for the OTC webinar. I am your host, Wilmien Davis. Lovely to see you here. This is the 10th webinar in our series this year. From February until November, we gave you a webinar once a month, all focused on the gas landscape in South Africa. We are very excited to have you here and give you our last webinar for the year. We've talked about the future of gas. We've talked about practical solutions of gas, the regulatory environment. We talked about case studies. We've talked about LNG, small-scale LNG, importing. So many ideas how one can overcome the looming gas cliff in South Africa. We had Sasol who came in and said how they will assist to give us a bit more time before the gas cliff hit us. And today we are going to focus on a bit more on LNG. If you've missed any of the previous webinars, it's okay. We post the link on YouTube. We post the webinar presenting link on YouTube, and then later we present the Q&A on YouTube. So if you miss out, it's there to watch, especially now during the holiday. If you get a little bit bored, you can go and watch some of our videos. Please subscribe to our email list if you don't want to miss out on any of the webinars. You can also see some of our activities on our LinkedIn page. But today's webinar, we focus on the infrastructure projects for gas imports into Southern Africa, one of the options to overcome the gas cliff. We're going to look at what is required to get LNG into South Africa. What's the cost involved as far as we can find out, and more details about the projects that's been implemented there. We want a practical phased approach to the development of the infrastructure. We don't have necessarily government might not do it. We might not have major investors to do it. So what can we do practically to get gas into South Africa in time for the impending gas cliff, to use that resources effectively? But without ado, let's get into these very, very interesting speeches that we have prepared for you today. First up, we have Yuri Steyn. Yuri Steyn, an OTC director. He has 40 years of experience after he graduated as a chemical engineer, covering many fields, from process engineering to sustainability to effective management areas. And at OTC, we benefit from all those skills because he's the OTC chairperson. He looks into environmental matters, inherent safety design, water treatment, risk management, decarbonization, renewable energy, and so much more. And today he's going to demonstrate all of that for you in a very short presentation that he has prepared. Yuri is what infrastructure is required to import gas into South Africa. Without further ado, Yuri Steyn, the infrastructure required for gas imports into South Africa. Thank you, Yuri.
Wilmien indicated, I'm going to give you a brief introduction to the type of infrastructure that is required for gas imports into South Africa. Just by the way of introduction, some background, and you probably know most of these things. LNG, or liquefied natural gas, is a way to move gas long distances when a direct pipeline is not feasible. The global demand for LNG has significantly increased and will continue to do so. And as you can see in the graph, this is from the BP Energy Outlook published in 2024. They show in the light blue line how LNG traded volumes were expected to reduce to the year 2050 to get us to net zero situation, compared to the current trajectory shown in green, where it goes to over 1,000 billion cubic meters of LNG being traded. That's quite a significant difference. And some of the reasons for it, I think you know, the EU has decided to phase out Russian gas imports. as part of its Repower EU strategy. So that means they have to bring in gas from elsewhere, and the only way to do so is by LNG. LNG has a low volatility and can be transported at low pressure compared to compressed natural gas, which is typically transported at pressures of up to 250, 300 bar. And in its compact liquid form, natural gas can be shipped in special tankers to terminals around the world, and at these terminals, the liquefied gas can be returned to its gaseous state for distribution to users in country. Right, let's have a look at the LNG supply chain very quickly. Gas is sourced in gas fields. It's shown there. Then the gas is cleaned and dewatered. It's compressed and transmitted via pipeline to large-scale liquefaction facilities, and these are typically at the coast. Once you've liquefied it, of course, you have to store it in tankers. You can load it from the loading terminals into transport vessels. This long green line shows the long distances you can transport it by sea up to an LNG receiving terminal where it can be stored and regasified either in what's known as an FSRU, or a floating storage and regasification unit, or land-based facilities. And from there on, it's again converted to natural gas, which is then distributed by pipeline to the final consumers. What we're going to focus on today is this little section of the network. And if I enlarge it somewhat, I'm going to be focusing on the receiving terminal part of it and the storage and regasification side. And the next speaker, Freek van Heerden, will talk more about the distribution side of it. Okay, if we look at the port and marine infrastructure required, obviously you need deep water berths. You need to be able to accommodate these LNG carriers. Typical capacity, 125,000 to 174,000 cubic meters capacity. And there's an example of such a carrier vessel shown from the top. You need mooring and unloading facilities. This includes things like cryogenic arms or flexible hoses for LNG transfer. And of course, dredging and navigation aids. You have to ensure that large LNG vessels can get into your ports and be able to maneuver safely. Right. Just another example of what these carrier vessels look like. The left-hand side, there's the original versions, so that's so-called Moss-type vessels. And on the right-hand side, I show the membrane-type vessels. Looks a lot sleeker, and they are also somewhat safer than the Moss-type vessels. If we look at the storage and regasification portion of it, as I indicated, FSRUs, or floating storage and regasification units. These are quick to deploy solutions. They can be used in the ports of Richards Bay and Ngakura. If we look at the onshore facilities, you would require onshore LNG tanks. These are large cryogenic tanks, up to 220,000 cubic meters for long-term storage of LNG. And of course, regasification systems, and this is required to convert the LNG back into natural gas as required for projects planned in the area. In the picture, I show an FSRU. This is the green vessel in front, but if you look closely, there's a black vessel behind it, the one with the 4 domes on it. That is a supply vessel. And this one, the green one, is the storage and regasification unit. Some more examples of what an FSRU looks like. Large ships with the tanks in them and the regasification units. But you can also have custom built ones that doesn't look like a ship anymore. And this one has a totally square base. It has to be moved around with the help of a vessel. This is what an LNG regasification unit look like. LNG regasification means you have to heat it above its boiling point, which is minus 262 degrees. So you just have to heat it above that, meaning you pump the gas into, or the natural gas, liquefied natural gas into these vessels, and by heat exchange with the ambient air, the first one, top left, heat exchange with ambient air, it converts to gas again. But if that's not sufficient, you can have what is known as a forced air LNG liquefier, regasifier, or an open rack vaporizer, where it's similar to these upright vessels, but you spray water on top of it. The water obviously gets cooled down in the process and works well if you're at the coast, but there are limits to the cold water, the temperature that you can put back into the ocean if you don't want to harm the sea life. Submerged combustion regasifier units, that's where you have the tubes in a liquid bath and you heat it up by gas. And lastly, in terms of infrastructure required, pipelines and distribution. You obviously need pipeline tie-ins, connections to existing networks like the Lily pipeline, and potential expansion to Gauteng and industrial hubs. Truck loading bays for transport of LNG. This is small scale to off-grid industries and for the use of the transport. And future interconnections linking coastal terminals with inland demand centers. Value chain economics. It's very expensive to move LNG around like this. And if you look at the graphic, you'll see that producing natural gas and getting it to the coast in its gaseous form, if we look purely at operating cost, that forms typically 11% of the total expenditure. Liquefying it and storing it at the coast of origin can take up to 40% of the operating cost. Shipping it, 20%. Receiving it on the other shore and regasifying it, another 20%. And then, of course, distribution to the consumer. But if we look just at liquefaction and receiving and regasification, that is very close to 70% of the total cost. Provision must be made for alternative gas supplies to overcome the looming gas cliff in South Africa. So we don't have too much of a choice in this matter. We have to go this route. But we also have to utilize any in-country resources. And these must be developed as fast as practicable to minimize LNG imports. Another source in the region is, of course, Botswana coalbed methane, which can be converted to LNG in Botswana and also imported into the country. And a phased approach will best accommodate South Africa's LNG import ambitions. If we look at a phased approach and say phase one, it's a notification that I have to hide. Phase one, quick start import capacity, and this can take anything up to 5 years, with the objective of securing intermediate LNG supply to bridge the gas shortfall and support gas-to-power projects. We'd need a floating storage and regasification unit, because these can be manufactured quicker than building on-land facilities, with a primary hub at Richards Bay, as I've indicated before, a secondary hub at Ngakura, which Ngakura is the Xhosa word for Coega, so it's the port at Coega. Port and marine upgrades, LNG berths with cryogenic unloading arms and dredging for large LNG carriers. Integration of gas-to-power facilities, 3 gigawatt gas-fired power plant in Richards Bay, and tying into the Eskom grid to stabilize supply from there. And domestic and regional gas supply, develop at maximum speed to reduce imported LNG, and this can be delivered either as compressed natural gas or liquefied natural gas, depending on the distance to the consumer. Phase 2 is expansion and onshore anchoring. This can take 5 to 10 years from now. The objective is to transition from stopgap FSRUs to permanent infrastructure and expand the inland reach. Onshore LNG terminals, build several large tanks, install high-capacity vaporizers, develop the pipeline, extend from Richards Bay to Gauteng, interconnect with the Lily pipeline. Domestic, same as before, deliver as CNG or LNG or tie into pipelines once the supply and the quality has been proven sufficiently. And import LNG from the Botswana coalbed methane fields. And optimize industrial integration, try to anchor the demand in the Richards Bay Industrial Development Zone, and expand LNG use in industry and transport. And the graphic shows what such an inland storage and regasification facility could look like. Phase 3, now we're talking 10 to 20 years in the future. Regional integration and energy transition, with the objective of positioning South Africa as a regional LNG hub and to align with decarbonization objectives. This talks about a regional gas grid, interconnect Botswana, Namibia, Zimbabwe, and Mozambique for cross-border trade in gas, and enable reverse flow to balance supply and demand in different areas. We have to diversify LNG supply, which means long-term contracts with countries like Qatar or the US Gulf or West Africa. And we have to be able to blend with regional pipeline gas. Domestic and regional gas supply. And if I say domestic supply, this is the Kineticos and the Renergens of the world, and whoever else wants to operate in this arena. Maximize local production and include shale gas in the future thinking. And again, deliver as compressed natural gas or liquefied natural gas to remote areas, but ideally tie into the pipeline network. And strategic storage, large-scale LNG storage to ensure energy security for the future. But what can also be done during this period is to prepare these terminals for future hydrogen imports or exports. South Africa has been recognized as a country with the potential to produce significant volumes of hydrogen based on our wind and strong sunlight. So we can be an exporter of hydrogen in future, and these facilities can be converted to accommodate that. Wilming, that is my story for now. So I go back to you, and I thank the audience for listening.
Thank you, Yuri. Wow. I love those pictures. It just makes the theory so much more real to see it. And I can imagine if you stand there on the harbor and you look at these big ships, you really get an idea of how intense, how much is required to bring it in. So Yuri has brought gas from international into South Africa via the coast. Now Freek is going to help us to see how we're going to distribute it in the rest of the inland. Now, many of you know Freek very well. He's also presented more than once at the webinars. Freek has more than 40 years experience in process and project engineering on oil and gas projects, not only within South Africa, but globally. His CV lists a few things he specifies in, but I personally think we must rather list the technologies that he does not specify in. That list will be shorter than the ones that he knows a lot of. But in OTC, he leads the technical team with all these different technologies and all of his experience. And with that, we hand over to Freek, who's going to talk about gas infrastructure reaching the end users. Freek van Heerden, gas infrastructure reaching the end users. Thank you, Freek.
Okay, so I'm going to talk a bit about how to get from the coast. I'm sorry, Wilmina, I don't have pictures. I just have drawings, so you may not be very happy. Anyway, just joking apart. So Yuri mentioned this slide with the sort of pipe network. I'm going to now discuss what happens on this system or could happen. This is not an engineering presentation or a justification of certain things. It's more like a visualization type of thing, using information and stuff from the gas master plans and all these things and some other ideas, just to say what could perhaps happen and what is practical and so on. So if you look at this picture, we always zoom in on this gas network here and we say, yo, look at this pipe work here in South Africa. And when I zoomed out on Google Earth, I thought, oh, it is a very small bit of South Africa that's served by this pipe network. And that realization sort of struck me and said, well, what and why is it looking only like this? Bringing in 180 petajoules from Mozambique, roughly. It started at about 100 originally, if I remember correctly, reaching South Africa in about 2004, round about there. And these are the consumptions in the different regions. This line going down to KwaZulu-Natal is, of course, methane-rich gas, and there's also the line going to Witbank here with some methane-rich gas. So what can we do now? There's been a number of ideas around where can we bring LNG in. Yuri mentioned some. There's been talk about linking in here at Valankulos, Maputo or Matola, Richards Bay, Ngakura, if I didn't pronounce it right, maybe Mossel Bay, Saldanha. So there are a number of places where you could potentially bring things in. I sort of am using a sort of idea of, say, in the end, we want to say, let us produce 20 gigawatt of gas-powered electricity, just as sort of an anchor discussion. I'm not of the opinion that 3 megawatt of power in the long term is really enough, for example. So if we say 20 gigawatt of power we want, that's say roughly 20 million tons of LNG. This stuff here coming in if we use LNG from imported LNG, a lot of these customers cannot really afford it. So I sort of temper that down and say about 100 petajoules a year or 2 million tons. Import terminals on land, at least 3 million tons a year. FSRUs, maybe 1.5 million. What are we looking for? Say maybe 2 terminals at least, not just one. So if you add that all up, we can say potentially we can have 4 or 5 terminals around the coast. Some could be bigger, some could be smaller, to bring LNG in. Is that feasible? One could use bulk breaking points to bring LNG to smaller places. Let's say, for example, to Mossel Bay or somewhere you could reload perhaps and take smaller barges to places. So that's sort of the concept in terms of LNG, bringing LNG in. The next one is, what do you now do? The LNG now sits at these points. There's been a lot of talk to say you generate power here, and you need an anchor to justify an LNG terminal. So generally people say put up a 3 gigawatt power station here, and wherever you do that, but now you must get the power out to the customers and so on. So this is one of the problems. How do you get the power, especially if you bring LNG in here rather than where most of the power is used around here? And I put a big cross here. This LNG, I believe, is too expensive for a large number of industrial users. It's definitely, I think, too expensive for Sasol and some of the other people here. So it doesn't really help what I call industrial use, the sort of people that's presently on this grid using power. So what could be the next step? In the gas plan and so on, they talk about corridors, pipe corridors. And the one option could be to bring a pipeline around here and to be able to get the gas to where you need the power. It is quite interesting that what we found is that it's cheaper to bring power to a place where to bring gas to a place where power is required, rather than make the electricity somewhere and have long transmission lines. That is quite surprising to me, but it looks like that is better. So the idea here is that you transport gas around through pipelines and you make the power where you need it. So there's local power here. I think there's quite a bit of power required around Cape Town area and so on. This could be, let's say, a 6-year exercise, perhaps. Maybe I'm not optimistic, but you can actually get gas and LNG in, and mainly for power production is my view. This pipeline is 1,600 kilometers. Estimate you need about 3 gigawatt of electricity offtake along the pipeline to roughly justify it. This sort of 1,200 kilometers. The original Maputo pipeline, as I said, was justified on about 100 petajoule anchor load from Sasol at that stage. So what can we do otherwise then? So let's just look a bit at small-scale LNG. We have spoken quite a few times about these local gas fields. Yuri mentioned them also. So there are reasonable progress in certain areas of starting to produce LNG. I think the Botala one is quite well known. Kinetico FFS one is quite well known, that we can produce LNG and bring them to the Joburg area or wherever. Also small-scale LNG imports. This is a little ship, not a big ship, to either via ISO containers or sort of what we call a ship-to-shore type of operations where you can offload directly into tankers and cartage around. You could do that at various places along the coast, actually. These things, or the LNG produced this way, is not necessarily all that cheap because it's quite small scale. It is starting off productions globally and locally. Over time, I think as the operation expands, the LNG will become cheaper, but mainly for fuel replacement or industrial use where people can afford it more than anything else. There has been quite a reluctance by port authorities and those people to allow LNG ships and things into harbors and so on. The perception is that LNG is extremely dangerous and extremely hazardous, but LPG ships are generally allowed in. There's quite a few LPG import terminals. LNG is actually a lot safer than LPG. It cannot cause things like levies and so on easily. So there is this misconception, I think, that we have to work on a bit, that it is not a dangerous thing. A lot less accidents on LNG logistics than even diesel or LPG and so forth. Next step, thing that's been talked about a lot is bringing gas from either the Namibian side or the South African side here where those big gas fields are. This pipeline, about 1,200 kilometers, you need about, say, 150 petajoules of gas along this line, but this can be a big line. This gas, I think, can land here at a price that is affordable to the industrial users here and so on. So this really is an excellent way to get affordable gas in at this point here. You can take the LNG that's produced here in the previous slide, and those things can supply niche LNG markets where you need LNG as LNG, for instance, in vehicles, rather than gasify it and put it in for gas users and so on. So there's still a place for all these sort of things, and both options can work. I didn't mention too much about the Mozambique pipeline up from Pemba or that area. That's over 2,000 kilometers. It's very quiet about that pipeline. Not sure whether there's much happening. I don't think we could find anything at the moment on that. So now we have that option. You could actually bring a pipeline along here in this option to bring gas to the coast in this area. Now, what could it look like in 15 years or so? It's just my sort of, as I said, visualization. If we can get gas in, affordable gas, that's a great solution. In the end, it will be a mix of things, where some LNG imports, some pipeline gas, local production. The demand is very big, and we actually in previous presentations spoke about that and the amount of gas we think can be taken up at lower prices and so on. So a complementary solution. Unfortunately, at the moment, quite a bit of the people in this thing see it as a competitive thing, where one supplier or one area wants to compete with another area. It's not. The market is big enough, and I think there is more than enough space for everybody to work together and help us achieve anything that's really viable for the country. Example, India, and this, if you look at this India map, and you can see what they've achieved here. So they put in import terminals, they expanded the pipelines enormously. These are all the terminals that were put in. Interesting, a lot of them are 5 million tons. Then there's one very big one. So how did this happen? Focus on import terminals. And remember, India is also, they've got a lot of coal and so on, but they sort of started focusing on the gas area quite a bit of time ago. Import terminals, pipelines, they have something like 2,000 truck filling stations, LNG things along the coast, with virtual pipelines and all that. And their focus now is to start developing the coal bed methane resources in country. So I just thought this is a very nice, interesting way that it happened. That could be a bit of an example. We have a lot of resources to our sort of in our pocket here. I just put this on somewhere as a thing to say, yo, there are lots of dots and flames and things here. Let us put shoulder to the wheel and see if we cannot do this. It's here, it's in our hands. We must just achieve it. And that's where I end. Thanks, Wilmien.
Thank you, Freek. Freek, you made my job very difficult. Every time I want to type a question for you, the next 2 minutes you've answered that question. So I want to challenge our audience. I hope you have questions for Freek that he has not answered yet during his presentation. And did you see that Freek talked about its groundbreaking ideas and work that we need? But we need to break a lot of ground to be able to lay so many pipelines in South Africa. But yes, let's take that advice. Let's put our shoulder next to the wheel and start breaking the ground to be able to transport the LNG to wherever we need it and to make South Africa grow and industries grow. It will be good for each and every person in our country. Our third, but not least, presentation for today will be from our external presenter today, Stephen Rothman. Now, Stephen has a strong foundation in strategic management, and he has successfully developed businesses from greenfields projects to mature. Really a skill that I take my hat off. I don't have any idea how one does that. But for the past 16 years, he specialized in the gas sector, playing a pivotal role in bringing global technologies into Africa. His work has been instrumental in introducing and expanding these technologies within the sub-Saharan Africa region. Currently, he's CEO of LNG Hub, a company distributing LNG as transport fuel to lots of places, industry and mining, small to medium power generation, and hybrid power projects. So very excited to hear from someone who's already putting his shoulder onto the wheel and make it happen. Stephen is going to talk about small-scale IRDD facility. Stephen Rothman, small-scale IRDD facility. Thank you, Stephen.
All right, can you see that?
Yes, it looks good.
All right, yeah, thank you for the opportunity of introducing LNG Hub. LNG Hub is focusing on small-scale LNG imports. Our sweet spot is somewhere around 100,000 tons. As soon as we go over 150,000 tons, we need some modifications to port, which is, as we know in South Africa, dealing with TMPA, very difficult to get those approvals. But what we did is we've set out and we investigated all the various ports, and we have started with a import, regas and distribution depot that we're looking at launching by July 2027. The business was incorporated in May 2022. What we did is put a team together somewhere around 2021. We started actively working as a team, investigating ports of entry. Initially, our ambition was to link into the BGC project. That, as we know, didn't get to financial closure, and we were pushed harder to see what solutions can we do, bring into the South African market. How can we enter the market focusing on the downstream distribution end? We managed to get our NERSA licensing in May 2022, and as I said, we narrowed down our focus to Richards Bay itself, July 2027 first supply. Now, the business evolved. We set it up having in mind we will then buy LNG from our neighbors. We will distribute downstream distribution, and we are looking at a fuel alternative. We're not looking at substituting the Sasol pipeline, and I'll show you now where we're looking at fitting into the supply chain. What we found as well is going into this market, we found a lot of people wanting information, and we went into a lot of consulting and doing consulting work where we provided solutions. We looked at certain projects using the waste gas, supplementing with LNG supply. And we then said, what we need to look at is not just the small scale, but how do we offer an overall solution to companies? We also started introducing LPG mix, not our speciality, but we're contracting that out to direct suppliers. The aim with that is specifically where we're looking at setting up companies, for example, in the Cape region, with a focus on when we structure and set up, let's say, an alternative for paraffin, we would be ready then to switch that company to LNG in about 3 to 5 years' time. So we've evolved as a company, not just looking at the downstream, but looking at overall solutions and looking at how we can also link into the pipeline. So we've had a lot of customers come to us and said, but in the long term, when the pipelines are operational, they want to be able to switch back because that gas will be cheaper. And we've provided some solutions on that, where we do a 3-year contract, where we're looking at then relocating our equipment and providing temporary solutions. But those are limited. Those are targeted customers that we can then service. So going a bit into the supply chain and where we fit into the supply chain. On the left-hand side, as everyone is aware, the large terminals, that's been the focus. That's been Transnet Port Authority's focus. We don't see that as competition. Once the terminals are operational, we would source through the terminals, and we would create depots, pretty much like your diesel infrastructure, where we're looking at 24/7 distribution. We opted to choose sites, and the first site out of the port area. Reason is we can then deliver 24/7. We don't have the congestion in and out of the port, and we would be able to give our customers buffer storage. Also, we know the ports have a lot of labor issues at certain times of the year. So we built in buffers to be able to carry stock for at least 2 weeks. And at the customer site, we've also allowed for a week. So we built in buffers to make sure that we can supply. The cheapest solution on a small scale is the middle one, where you're looking at a barge or FSRU linked to a cryogenic pipeline berthing area, linked to your storage and distributing. Second cost-effective one on the small scale is ship to truck. We went through a process for almost 2 years with TMPA, went up to the Ports Authority, went legal with the basis of being referred back to Transnet, and we got no traction on the ship to truck. We then focused on how do we economically import via ISO containers. Our project now allows, we're looking at between 15 and 18 days rotation, approximately 200 ISOs, that limits our capacity about 4 picojoules of import, phase one. Phase two, once the Grindrod berthing area has been upgraded, we would be able to get to roughly about 6 picojoules. So again, we're filling a niche. We are a fuel that is part of the mixture, part of CNG, LPG, and then we would be the downstream small-scale distribution, and in some cases, fill a bridging gap. So markets we've been focusing on is, and we've spoken about them previously, is we are looking at hybrid power solutions. A lot of mining companies we've been working with on that. Industrial, straightforward supply, alternative paraffin, diesel, heavy fuel oil, but also limited focus, why we call it import regas distribution, because certain customers in Richards Bay will look at direct supply via pipeline once there is no gas available. So we have allowed for that. And then with Puma Energy, we've got a long-term project where we launching a pilot phase July next year to develop filling stations. And what I thought I'd show the audience is if you look at the fuels, and this is 2024 figures published by government figures, you can see we're looking beyond. We are not targeting the 60 picojoules in Gauteng and the 17 picojoules in KZN. We're saying we would take on certain of those customers targeted, but what are the other markets? Paraffin, 43 million gigajoules, furnace oils, LPG, and we're focusing obviously on the bulk side. Giving you a bit more background on what the import regas distribution depot facility looks like. We've secured land at, and I think most of the audience will be aware of it, of Bayside Smelter. We would be looking, if you look on the right-hand side there, initially using Transnet's multi-purpose berth, and then once Grindrod has developed this, they estimate around 2028, we would move the vessels coming into there. We then would be rotating the ISOs, as I said, every 15 to 18 days. And our process, we're looking at, as there's a site of the depot where we're looking at regassing into the pipeline, and we're also looking at distribution via loading gantries to customers that have storage on site. So it's just a illustration. So your ISOs would come in, it'd be pumped over to storage. We'd have, say, 18 days to clear out our ISOs. We would then look at vaporizing into the pipeline, also pumping back into our loading gantries and loading our tankers at the facility and distributing to customers. That's what a typical customer would look like. Would be a smaller type of customer, 60 or 80 cubic meter tank. The tanker would come in, pump the LNG across, they would have vaporizers, and we would then supply the gas to the customers. We've done quite a few projects and proposals. Left top illustrates a facility, for example, footprint 3,000 square meters, 1.6 picojoules, storage capacity about 1,750. And so what we've done is we've done a lot of modeling, we've got a lot of term sheets, and we're now moving, once our EIAs are completed, which is expected to be announced on the 12th of December, if we go to the EIA timelines, then we would go through to gas offtake agreements with potential offtakers. The involvement of our facility, and this is where small scale comes in, and you can even do smaller, like for example, commercial centers, office. You start looking at rigid trucks distributing from your depot and topping up smaller filling facilities, and suddenly you then can compete where traditionally you would be looking at a 25,000 gigajoules plus a month customer. Now you can start looking at customers that are using about 2,000 gigajoules a month equivalent. Giving a bit more on our filling station strategy. As I said, the pilot project, we're looking at 2 stations, one just outside of Gauteng, one between Pietermaritzburg and Pinetown, starting off with approximately 10 trucks, going up to 20 trucks, running them for 6 months, and then we are designing the filling station so that it will have the capability of servicing up to 600 trucks a day. The corridors we're looking at to complement our facility in Richards Bay is your N17 going down to Richards Bay. So it's your coal, your mining trucks running down to Richards Bay itself, and then obviously the N3 corridor. These are just illustrative of storage and facilities you could set up, as is demonstrating overseas simple facilities. The one actually on the right is LNG and LCNG, so it can do both LNG for trucks and for mid-sized vehicles, bakkies, and that it can do CNG and dispense from the same storage facility. We're also working with a couple of the bigger projects on the yellow fleets, and those are specific projects that will come online in phase 2 of our project. That is us. Wilmien, back to you.
Wow, Stephen, thank you. You guys are really putting your money where your mouth is now. Seeing a problem, seeing a need out there and start doing it. I live exactly between Pietermaritzburg and Pinetown, as you said. And since Koos previously talked about an N3 project and every time I go close to the highway, I look at everything with different eyes. So I'm very expectant to see your LNG refueling hub that you're going to put up there. Thank you again to all the speakers for the time and effort that you put in to prepare these. I know 15 minutes is very little time. Every time we think, oh, we can spend a whole 3 webinars on only one of these presentations. So we really appreciate how you compacted to give us the core of what you want to say. But we know there's so much more out there. We haven't exhausted any of these presentations or these topics that we have presented to you. Although today is the last webinar for 2025. But we're not going to leave you hanging. We definitely will be back with new energy, new ideas to continue on this journey, looking not only at gas, but looking at some other things as well within the energy landscape. What alternatives are there? How can you get clean energy out there? In February, we will definitely have another webinar where we want to update you on the landscape. Remember, February this year, we had a big presentation on showing this is how we see the landscape looking like. And we will put the whole 2025 in perspective and see what we predict for 2026 or where we see the trends are heading to. So I do hope that you're going to be joining us early next year again. And if there's any other topics that you want to hear more of, or other topics that you want us to expand on or introduce, please let us know. We want to create content that is valuable for you and that will get you to come back every month and listen to what we have to say. But thank you for your support so far. It's been a brilliant journey. With that, the official part of the webinar is finished, and I'll introduce the Q&A session in a few seconds. Thank you for joining us up till now.